children, welcome to maths classes. Children, today let's solve example 6 in the chapter number systems of class 9 NCERT maths textbook. Show that 3.142678 is a rational number. In the other words, express it in the form of P by Q, where P, Q are integers and Q not equal to 0. So here they gave a decimal expansion. You should express it in the form of P by Q. Okay children, let's see. 3.142678. This is terminating children. Terminating in the sense terminating decimal expansion, so it will be a rational number. But they are asking to express in the form of P by Q. So let's see how can we do that. After decimal, how many digits are there children? 6 digits. So you can write it as 3142678 by 6 decimal digits after decimal point. So you write 100,000. You get units, tens, hundreds, thousands, 10,000, lakhs. 10 lakhs. So 314, 31 lakhs, 42,678 by 10 lakhs. So we are able to express it in the form of P by Q. And Q not equal to 0. Here both P that is the numerator and denominator are integers. So we can tell that it is able to express in the form of P by Q. So this decimal expansion is a rational number. After decimal places you have 6 digits. So you write in the denominator after 1 6 zeros. It will become 10 lakhs. 31 lakhs 42,678 by 10 lakhs. We are able to express in the form of P by Q. So it is a rational number. It is a simple problem children. Example 7 children. Show that 0.333 and so on, that is equal to 0.3 bar, can be expressed in the form of P by Q, where P, Q are integers and Q not equal to 0. They are asking to express this number, this decimal expansion 0.333 and so on, in the form of P by Q. Children, observe this children, 0.333 and so on. What is this? It is a non-terminating. It is a non-terminating and recurring. Digit 3 is repeating. So it is non-terminating recurring decimal expansion. That means it is a rational number. So children, can we express this in the form of P by Q? Yes, we can express this in the form of P by Q. And they are asking that children, they are asking to express this in the form of P by Q. So, let us assume this 0.333 and so on as x. Let x is equal to 0.333 and so on. Then children, how many digits are repeating children? In this 0.33, only one digit 3 is repeating. Remember children, here in this question, only one digit after decimal point is repeating. One digit is repeating. So we multiply both sides by x to solve this problem easily. If only one digit is repeating after decimal point, we multiply by 10 on both sides. If two digits are repeating, so if the question was 1.3737 and so on, we will assume x as 1.37 as two digits are repeating here. 3737, two digits are repeating after decimal point. We will multiply with 100x. 100. We will multiply with 100 on both sides. If two digits are repeating, to solve the problem easily. If 3 digits are repeating, if it was 2.786786 and so on, we will multiply both sides with 1000. Because 3 digits are repeating. If you do in this way, the problem can be solved easily children. So here only one digit is repeating. We multiplied both sides with 10. 10x is equal to, what is 10 into 0.333 and so on? You know easily children, the decimal point moves one digit right side. 10 into 0.33 is 3.33 and so on. See children, 10 into 71.68. We are multiplying with 10. Then it will move, decimal point will move one digit right side. It will become 716.8. If it is 100 into 71.68, decimal point will move 2 digits right side. It will become 7168. Okay children, 768.0. That means 7168. This you all know. So 10 into 0.333 and so on is 3.333. Now 10x is equal to, write this. Split this into two numbers. Split this into sum of two numbers. In that two numbers, one number should be 0.333 and so on. To solve the problem easily, in the first step, check what are the number of decimal after decimal point, what are the number of digits repeating. Here one digit is repeating after decimal point. So multiply both sides by 10. Then we got 10x is equal to 3.333. Then split this number into sum of two numbers. In that one number should be 0.33. So you will write 3.33 as 3 plus 0.33 and so on. So one number is 3 and another number is same as this. 3 plus 0.33 is nothing but 3.33. So 10x is equal to 3 plus 0.333 is nothing but, we assume 0.33 as what? X. So we can replace this with x. 10x minus x. Send this x to LHS side. You will get 10x minus x is equal to 3. 9x is equal to 3. That means, that implies x is equal to 3 by 9. 3 ones, 3 threes. So the result you got is x is equal to 1 by 3. That means x is nothing but 0.333. So we are able to express this 0.333 as 1 by 3. We assumed x as 0.333. In the final we got x is equal to 1 by 3. That means 0.333 is equal to 1 by 3. So this is the way you should do, children. Assume the given number, the given decimal expansion as x. Then check how many digits are repeating after decimal point. If one digit is repeating, multiply both sides with 10. If two digits are repeating, multiply both sides with 100. 10x, here only one digit is repeating, so 10x is equal to 10 into 0.33. 10x is equal to 10 into 0.33 is 3.33. Then split this number as sum of two numbers. In that, one number should be the number given in the question. We assume that as x. So that in the next step we can replace this number easily with x. 10x is equal to 3 plus x. Then you get 9x is equal to 3. X is equal to 3 by 9. That is 1 by 3. This is the way you should solve the question. Example 8, children. Show that 1.2727 and so on. That is 1.27 bar. Here 27 is repeating. So you keep bar on 27. Can be expressed in the form of p by q, where p and q are integers and q not equal to 0. So the question is very similar to example 7, children. So in the first step, what do you do, children? This number, what is given, that should be assumed as x. Let x is equal to 1.2727 and so on. Here, children, after decimal point, how many digits are repeating, children? The digits 27 are repeating. 2727 are repeating. That means 2 digits are repeating. So you multiply both sides with? Yes, children, correct. You multiply both sides with 100. 100 into x is equal to 100 into 1.2727 and so on. So next step, 100x is equal to 100 into 1.2727. Here two zeros are there. That means decimal point will move two sides, two steps right, two digits right, decimal point will move. So it will become 127.2727 and so on. Next step, children, 100x is equal to, in this step what should you do, children? You should split this number into sum of two numbers. In that two numbers, one number should be the x value. X is 1.2727, right? So you should split this into two numbers. In that, one number should be 1.2727 and so on. So how can you write that, children? One number should be 1.2727. So what will be the other number? 126. So 126 plus 1.2727 is 127.2727. Why do you do this, children? Because in the next step, we can write 100x as 126 plus 1.2727 and so on is nothing but x. So to write this easily, to solve the problem easily, we will split this number into sum of two numbers. One number is same as the number given in the question. So 100x is equal to 126 plus x. 100x minus x. X will come to the left hand side. 100x minus x is equal to 126. That means 99x is equal to 126. So x is equal to 126 by 99. Is this divisible by any number, children? Check if it is divisible by 3. How should check if it is divisible by 3 or not? 6 plus 2 is 8. 8 plus 1 is 9. 9 is divisible by 3. So 126 will be divisible by 3. 3 4s are 12. 3 2s are 6. 3 3s are 9. 3 3s are 9. Again 4 plus 2 is 6. So it will be divisible by 3. 3 1s are 3. 3 4s are 12. 3 1s are 3. 3 1s are 3. So you got answer as 14 by 11. X is equal to 14 by 11. That means 1.2727 and so on can be expressed in the form of P by Q, which is 14 by 11. The answer is 14 by 11. So children, here we first assume the given number as x. Then two digits are repeating after decimal point. So we multiply both sides, LHS and RHS with 100. 100x is equal to 100 into 1.27 is nothing but 127.27. Then we splitted this number into sum of two numbers. In that one number should be this. So we wrote 1.2727 plus what? 126. 126 plus 1.2727 you get 127.27. Then we replace 1.27 with x. 100x minus x is 99x. 99x is equal to 126. Then x is equal to 14 by 11. Example 9, children. Show that 0.23535 and so on, 0.235 bar is equal, can be expressed in the form of P by Q, where P and Q are integers and Q not equal to 0. Here the question given is 0.23535 and so on. Here what is repeating after decimal, children? After decimal point, digits 3, 5 are repeating. Only 3, 5 are repeating. So you will write 0.235. Bar will be only on 3, 5, not on 2, 3, 5, children. 2, 3, 5 are not repeating. Only digits 3, 5 are repeating. So you will write bar on 3, 5. Children, what to do, children? Yes, it is same as the previous problem. So first step, let x is equal to 0.23535 and so on, children. So children, observe children. After decimal point, what are the digits repeating? Digits 3, 5 are repeating. 2 is not repeating. Only digits 3, 5 are repeating. That is 2 digits are repeating. So you should multiply both sides with, yes children, 100. You should multiply both sides with 100. 100x is equal to 100 into 0.23535 and so on. So 100x is equal to, what is 100 into 0.23535? Decimal point will move 2 digits, right? When it is multiplied with 100. 100 has 2 zeros, so decimal point will move 2 digits, right? It will become 23.53535 and so on, children. What is the next step, children? 100x is equal to, how should you split this? You should split this into two numbers. In that one number should be 0.23535. So write this as it is first. 0.23535. Then think. So how will get the other number? From 23.535. Here you have 23.535. From that subtract 0.23535. We should write same number, right? One number should be same. So we first wrote this 0.23535 and so on. To check the To get the other number easily, just subtract one number we have. How do you get the other number? By subtracting 0.233535 from 23.535, you get that. Subtract. 5 minus 5 is 0, 3 minus 3, 5 minus 2 is 3. You get 23 here. 23.3. 23.3. When the problem is somewhat big, the number is big, if you do in this way, it will be easy, children. 23.3 plus 0.23 is nothing but 23.535. So, now next step, 100x is equal to 0.23535 is nothing but x. X plus 23.3. 100x minus x is 99x. 99x is equal to 23.3. That means x is equal to 23.3 by 99. Here what is the question, children? They said it should be expressed in the form of p by q, where p, q are integers. Is 23.3 an integer, children? No, it is a decimal number. Integers will not be in the form of decimal numbers, children. So convert it into an integer. How do you convert it? You can write 23.3 as 233 into 10 power minus 1 by 99. 10 power minus 1 goes down, it will become what? 10. So it will become 990. The answer is 233 by 990, or directly you can write decimal point into 10 power minus 1, it goes down, it will become into 10 in the denominator. So it will become 233 by 990. So now it is expressed in the form of p by q, where p and q are integers. 233 and 990 both are integers here. So x is equal to 233 by 990. X is nothing but 0.23535. We are able to express this in the form of p by q. Now children, example 10, children. Find an irrational number between 1 by 7 and 2 by 7. What they are asking to find? Irrational number between 1 by 7 and 2 by 7. Children, we already solved 1 by 7 in example 5, children. In example 5, we solved 1 by 7 and we got 1 by 7 as 0.142857, 2857, 142857, 0.142857, 142857 and so on. That is 142857 is repeating. So we write bar on this 142857. So 1 by 7 we got as 0.142857 bar. So if 1 by 7 is this, what do you get? 2 by 7. 2 by 7 is nothing but 2 into 1 by 7. So you multiply this with 2. What do you get, children? 142857. 0.142857 into 2. What do you get? 2 7s are 14, 2 5s are 10, 11, 2 8s are 16, 17, 2 2s are 4, 5, 2 4s are 8, 2 1s are 2. You get 0.285714 bar. So children, they are asking to find irrational number between these two decimal expansion. These two, 1 by 7 and 2 by 7. What is an irrational number, children? Irrational number is non-terminating and non-recurring. A number whose decimal expansion is non-terminating and non-recurring, that number is called as an irrational number. Non-terminating means that decimal expansion does not end at all, and non-recurring means it does not repeat. Here in rational number, this block of digits are getting repeated, but in irrational number that doesn't repeat. So you can write anything, children, between 0.142857 and 0.285714. You can write anything. After 14, what do you get? 15 you get. After 142857, after some digits you get 15, right? So you can write 0.15, anything we use. 0 1 1 0 5 6 7 8 9 3 2 1 1 7, anything you can write, children, because it is non-recurring. That doesn't repeat in the same thing, same manner. It doesn't repeat. You get 15011, again you will not get 15011. You get something, another pattern, other digits in random way you get. So you can write n number of digits. You can write infinite number of irrational numbers between any two rational numbers, children. You can write this. You can write after 0.1428, you will get somewhere what here it is 0.28. So before that you will get 0.27. You can write 0.27, 631272869 anything, any digits you can write in random, children. So finding an irrational number between two numbers 1 by 7, 2 by 7 is very easy, children, because irrational number is non-terminating and non-recurring. Just see this. What is 1 by 7? What is 2 by 7? 0.14 it starts. So write something after 14. You get 15. Before 0.28 you should write, children. That's it. Thank you for watching the video. Like, comment, share and subscribe.